Welcome to the fascinating world of game theory and optimization in economics. Game theory is a powerful tool that helps us understand strategic interactions between individuals, businesses, and even countries. By analyzing how different players make decisions, economists can predict outcomes in competitive and cooperative environments. Optimization, on the other hand, is about finding the best possible solution given certain constraints. Together, these concepts form the backbone of modern economic analysis. In this video, we'll explore how game theory and optimization work hand in hand to solve real-world economic problems, from pricing strategies to resource allocation. Game theory is the study of mathematical models of conflict and cooperation between intelligent, rational decision makers. It's not just about games in the traditional sense, but any situation where the outcome depends on the choices of multiple participants. Economists use game theory to analyze markets, auctions, negotiations, and more. By modeling these scenarios, they can predict how people will behave and what strategies will lead to the best outcome. This approach is essential for understanding competition and collaboration in economics. Optimization is the process of making something as effective or functional as possible. In economics, it often means maximizing profits, minimizing costs, or achieving the best possible outcome given limited resources. Economists use mathematical techniques to determine the optimal choices for individuals and firms. Whether it's deciding how much to produce, what price to set, or how to allocate resources, optimization provides a framework for making the best decisions in complex environments. One of the most famous examples in game theory is the prisoner's dilemma. Imagine two suspects are arrested and interrogated separately. If both stay silent, they get a light sentence. If one betrays the other, the betrayer goes free while the other gets a heavy sentence. If both betray, both get moderate sentences. The dilemma shows how rational individuals might not cooperate, even when it's in their best interest. This scenario is used to explain many real-world situations, from business competition to international relations. Nash equilibrium is a key concept in game theory. It occurs when no player can benefit by changing their strategy while the other players keep theirs unchanged. In other words, everyone is doing the best they can, given what others are doing. This concept helps economists predict the outcome of strategic interactions, such as pricing wars or negotiations. Understanding Nash equilibrium is crucial for analyzing competitive markets and designing effective policy. Zero-sum game, one player's gain is exactly another player's loss. The total benefit remains constant, so players are in direct competition. Classic examples include poker and chess, but zero-sum thinking also applies to certain economic situations, like bidding wars or market share battles. Understanding zero-sum games helps economists and businesses develop strategies to maximize their own outcomes while anticipating competitors' moves. Not all games are zero-sum. In non-zero-sum games, cooperation can lead to better outcomes for all players. Trade negotiations, business partnerships, and environmental agreements often fall into this category. By working together, participants can create value that benefits everyone. Game theory provides tools to analyze when cooperation is possible and how to structure agreements for mutual gain. Payoff matrix is a table that shows the outcomes for each player in a game, depending on the strategies chosen. It's a fundamental tool in game theory, allowing economists to visualize and analyze strategic interactions. By laying out all possible choices and their consequences, payoff matrices help identify optimal strategies and predict likely outcomes in competitive situations. Dominant strategy is one that yields the best outcome for a player, no matter what the other players do. If every participant has a dominant strategy, predicting the outcome becomes much simpler. However, in many real-world scenarios, dominant strategies don't exist, and players must carefully consider the possible actions of others. Recognizing when a dominant strategy is present is a key part of economic analysis. Sometimes the best approach is to randomize your choices. In game theory, this is called a mixed strategy. Instead of always choosing the same action, players assign probabilities to different options. This can make it harder for opponents to predict your moves, especially in competitive environments like auctions or sports. Mixed strategies add complexity to economic models but can lead to more realistic prediction. Not all decisions happen at the same time. In sequential games, players make moves one after another, with each move potentially affecting future choices. This is common in negotiations, bargaining, and many business scenarios. Game theory helps analyze these situations by considering the order of moves and how information is revealed over time. Sequential games often require careful planning and anticipation of others' responses. In simultaneous games, all players make their decisions at the same time without knowing what others will do. This is typical in situations like sealed bid auctions or setting prices in competitive markets. Game theory provides tools to analyze these scenarios, helping predict how rational players will act when they must decide without full information. Any economic interactions are not one-off events but are repeated over time. In repeated games, players encounter the same situation multiple times, allowing them to build trust, punish cheaters, or develop long-term strategies. This is important in business relationships, trade agreements, and even international diplomacy. Game theory helps analyze how repeated interactions can lead to cooperation or persistent competition. Optimization is at the heart of economic decision-making. Whether it's a company maximizing profits, a consumer choosing the best product, or a government allocating resources, the goal is to achieve the best possible outcome. Economists use mathematical models to identify optimal solutions, taking into account constraints like budgets, time, and available information. Optimization ensures that resources are used efficiently and effectively. Linear programming is a popular optimization technique in economics. It involves maximizing or minimizing a linear objective function, subject to a set of linear constraints. This method is widely used for resource allocation, production planning, and transportation problems. By translating real-world issues into mathematical equations, linear programming helps find the most efficient solution. Every optimization problem comes with constraints. These are the limits or requirements that must be satisfied, such as budgets, time, or resource availability. Constraints shape the set of possible solutions and ensure that the chosen option is feasible. Understanding and accurately modeling constraints is crucial for effective optimization in economics. The objective function is the heart of any optimization problem. It defines what needs to be maximized or minimized, such as profit, cost, or utility. By clearly specifying the objective, economists can focus their analysis and find the best possible solution. Objective functions are tailored to the specific goals of individuals, firms, or governments. Game theory and optimization are widely used in business decision-making. Companies use these tools to set prices, design products, allocate resources, and plan marketing strategies. By anticipating competitors' moves and optimizing their own actions, businesses can gain a competitive edge. These techniques are essential for navigating today's complex and dynamic markets. Auctions are a classic example where game theory and optimization intersect. Bidders must decide how much to offer, considering both their own value and what others might bid. Economists use game theory to design auction formats that encourage fair competition and maximize revenue. Optimization helps bidders determine the best strategy to win at the lowest possible cost. Setting the right price is a complex challenge for businesses. Game theory helps firms anticipate how competitors and customers will respond to different pricing strategies. Optimization techniques are used to find the price that maximizes profit while staying competitive. This combination allows companies to make informed decisions in fast-changing markets. Efficient supply chains are vital for business success. Optimization helps companies minimize costs, reduce delays, and ensure products reach customers on time. Game theory comes into play when multiple firms interact, such as negotiating contracts or sharing resources. By combining these approaches, businesses can build resilient and responsive supply chains. Negotiations are a classic setting for game theory. Each party tries to achieve the best outcome, often with incomplete information about the other's preferences. Game theory models help negotiators anticipate moves, identify win-win solutions, and avoid deadlocks. Optimization ensures that the chosen agreement is the most beneficial given the available options. Markets are arenas of constant competition. Game theory helps firms predict rivals' actions and develop strategies to outperform them. Optimization allows companies to allocate resources efficiently, set production levels, and respond to market changes. Together, these tools provide a roadmap for success in highly competitive industries. Oligopolies are markets dominated by a few large firms. Game theory is essential for understanding how these firms interact, set prices, and compete for market share. Optimization helps each firm determine the best response to competitors' moves. These models explain why prices in oligopolies often remain stable, even when costs change. Public goods like clean air or national defense benefit everyone, but not everyone pays for them. Game theory explains the free rider problem, where individuals have an incentive to benefit without contributing. Optimization helps governments design policies to encourage participation and ensure public goods are provided efficiently. Mechanism design is a branch of game theory focused on creating systems or rules that lead to desired outcomes. It's used in auctions, voting systems, and market regulations. By anticipating how people will respond to different incentives, economists can design mechanisms that encourage cooperation, fairness, and efficiency. Traditional game theory assumes rational players, but real people often behave unpredictably. Behavioral game theory incorporates insights from psychology to better predict actual behavior. This approach helps explain why people sometimes cooperate, trust, or retaliate, even when it's not the rational choice. It's a valuable tool for understanding real-world economic decisions. Evolutionary game theory studies how strategies evolve over time, especially in populations. Instead of assuming perfect rationality, it looks at how successful behaviors spread and persist. This approach is used to analyze trends in markets, social norms, and even biological systems. It provides a dynamic perspective on strategic interactions. In many economic situations, one party has more information than the other. This is known as information asymmetry. Game theory helps analyze how this imbalance affects negotiations, contracts, and market outcomes. Optimization can help design mechanisms to reduce the negative effects of information gaps, such as adverse selection or moral hazard. When information is uneven, signaling and screening become important. Signaling involves one party sending credible information to another, like a job applicant showing qualifications. Screening is when the less informed party designs tests to reveal information, such as insurance companies offering different policies. Game theory explains how these strategies work and how to optimize them. Principal-agent problems arise when one party, the principal, hires another, the agent, to act on their behalf, but their interests may not align. Game theory helps design contracts and incentives to ensure agents act in the principal's best interest. Optimization ensures that these arrangements are efficient and cost-effective. Moral hazard occurs when one party takes risks because someone else bears the cost. This is common in insurance and financial markets. Game theory helps identify situations where moral hazard is likely and design incentives to reduce risky behavior. Optimization ensures that policies are both effective and affordable. Adverse selection happens when one party has more information about a transaction than the other, leading to poor outcomes. For example, in insurance, those most likely to need coverage are also most likely to buy it. Game theory and optimization help design policies that minimize adverse selection and ensure fair, efficient markets. Auction theory is a branch of game theory that studies how different auction formats affect bidding strategies and outcomes. Economists use this knowledge to design auctions for everything from art to government contracts. Optimization helps bidders and sellers achieve the best possible results, ensuring efficient and fair markets. Matching markets are where participants are paired based on preferences, such as job seekers with employers or students with schools. Game theory helps design matching algorithms that are fair and efficient. Optimization ensures that as many participants as possible get their preferred outcomes, making these systems work smoothly. Network effects occur when the value of a product or service increases as more people use it. Game theory helps analyze how these effects influence competition and market dynamics. Optimization helps firms leverage network effects to grow their user base and maximize value. Dynamic pricing involves adjusting prices in real time based on demand, competition, and other factors. Game theory helps firms anticipate competitors' pricing moves, while optimization algorithms determine the best price at any moment. This approach is common in airlines, hotels, and online retail. Resource allocation is about distributing limited resources to achieve the best outcomes. Optimization techniques help firms and governments decide how to allocate budgets, labor, and materials. Game theory comes into play when multiple parties compete for the same resources, ensuring fair and efficient distribution. Managing risk is a key part of economic decision-making. Game theory helps identify potential threats and anticipate competitors' moves, while optimization ensures that resources are allocated to minimize losses. Together, these tools help firms and governments navigate uncertainty and make better decisions. Governments use game theory and optimization to design effective policies. By anticipating how people will respond to new rules or incentives, policymakers can create regulations that achieve social goals, such as reducing pollution or improving public health. Optimization ensures that policies are cost-effective and practical. Game theory and optimization play a crucial role in environmental economics. They help design policies for managing common resources like fisheries or forests and encourage cooperation to address global challenges like climate change. By modeling incentives and optimizing resource use, economists can promote sustainability and protect the environment. In healthcare, game theory and optimization help allocate resources, design insurance plans, and manage public health interventions. By modeling patient and provider behavior, economists can improve outcomes and reduce costs. These tools are essential for making healthcare systems more efficient and effective. Game theory explains how countries negotiate trade agreements and resolve disputes. Optimization helps nations allocate resources to maximize economic gains from trade. By combining these approaches, policymakers can design agreements that promote cooperation and mutual benefit in the global economy. Game theory and optimization continue to evolve, with new applications in technology, artificial intelligence, and data science. As markets become more complex, these tools will play an even greater role in shaping economic decisions. Staying informed about the latest developments is essential for anyone interested in economics or business strategy. Sum up, game theory and optimization are indispensable tools in economics. They help us understand strategic interactions, design better policies, and make smarter decisions in business and government. By mastering these concepts, you can gain valuable insights into how the world works and how to achieve the best possible outcomes in any situation. Thanks for joining us on this journey through game theory and optimization in economics.